That was my plan. Okay. All right, next slide. So note well, this is a reminder, and please make sure that before you participate and contribute, that you know what your responsibilities under the note well are. Next slide. Remember, it's okay to attack a bad idea, but it's not okay to attack a person who has a bad idea. Please treat each other professionally and with respect. Next slide. Tips for participating. We are going to use the on-site tool for getting in the mic line. This makes sure that people who are not here in the room have an equal chance at getting to the mic. And please, so make sure that you have logged in. It also does the blue sheets for us automatically. Remote participants, please don't send video or audio unless you've been recognized at the mic line. And it really does help if you use a headset. Next slide. So the agenda has 8 sessions to it, or chunks to it. This is the first 3. The next slide for the next section. There's a whole bunch that are with the RFC editor. We have to talk about one of them. Then there's a bunch with the ISG, and we need to talk about one of them. And then there's a bunch of PKIX related documents. And then there's a bunch of SMIME related documents. And then there's ones we're going to think about considering. In this last batch, the CMC documents, we're going to move up because of the Friday issue. And in the earlier one block, the one about the freshness, we're going to move up and talk about earlier. So we will just, the proposal is we talk about them after the ISG documents and before the PKIX documents. Any concerns with that solution to the scheduling problem? All right, let's get going. We've got a lot of documents. So in the first block, there are 4 that are now RFCs, just a recognition that that's the case. Good job for the authors. And in the case of 2 of them, it's their first RFC. So awesome. Congratulations, Tomafumi and Joe. Moving on to the ones that are with the RFC editor. The first one, John, do you want to say anything about ChemRI? No. All right, nothing happened there. The next one is policy graph, and I am unaware of anything that needs brought up about that. Okay. The next one is end-to-end email guidance.
I don't think that needs any feedback, Russ. It's the header protection that we'll talk about in a little bit.
That's what I thought. Good. And then the next one is 5990 BIS, and there's slides for that. I made them. Okay, next slide. So as part of the preparation for IETF meetings, IANA goes through and looks at what's on various agendas and does a quick review. And they notice that 5990 points to this one algorithm identifier in the SMIME object arc, and 5990 uses it but doesn't update the registry to point to it, so that anyone who were to look up that code point would know what document to go read. And a developer noticed that the document did not explicitly point out that the KDF must produce the output that's the same size, sorry, not side, size of the key encryption key, so that one line was added. Expect an update to resolve this. The RFC editor is aware that this is coming and moved it to auth state so they wouldn't start editing it. Any questions about either of those very minor changes? Okay, so we'll go back to the list, the SHA-3 hash document. There's no update. It's just waiting for the RFC editor to have cycles. And the OCSP nonce update is in the same situation. So that's the updates for the ones with the RFC editor. Now to the ones that are with the ISG. Cert binding for multi-auth, I'm unaware of any open issues that need to be raised.
This is Allie. Just real quick, there was a discuss and we sent a response on 620. And once that's lifted, I think we're ready to go. So just waiting on that.
Okay, thank you. And 5019 BIS, I'm unaware of anything on that one.
Hi, Sean Turner, real quick. We're just waiting to get the approval from a previous author of the previous version so that we can avoid the 5378 text. Apparently that is in the works. We got approval from one, so we're just waiting on the other one. So as soon as that's done.
We only need one of them to get out from under this, and one of them's here.
Excellent.
May not be in the room, but I saw them at the meeting. So, yeah, I was surprised too. Hadn't been here for years. Okay, and the next one is header protection, and that we have slides for.
Hey folks, this is Daniel Kahn Gilmore. I'm presenting on behalf of my co-editors, Bernie and Alexei. Next slide, please. This is about the header protection draft. There has been quite a bit of work since the last IETF. Last IETF was draft 20, and we now have draft 23 in the data tracker. There's been a major document reorganization. It is much more readable now. We have actually changed the mechanism for identifying the headers that the sender put on the outside of the cryptographic envelope, and I'll get to that in a second. And we have cleaned up the indicator for that the sender is doing this. Probably the most, and we also have guidance now for safe handling of replies and forwards. And we have broken out some of the algorithms that the document describes into pretty clear pseudocode. Next slide, please. There are some pretty significant changes here. We've renamed the HCPs that are present, thanks to feedback from other authors, from other reviewers. The HCP that provides no confidentiality is now called HCP no confidentiality, which is pretty reasonable. The baseline HCP is now called HCP baseline. In addition to hiding the subject, it also removes keywords and comments, which are noted as informational fields in RFC 5322. And we've replaced HCP strong with HCP shy, which removes some of the threading issues that we were seeing with HCP strong, and instead helps to mask some of the things that are sort of human readable information that the mail transport agents wouldn't need to know. Most significantly, we removed the wrap message scheme. So there is now a single scheme, which is now called header protection, not called injected headers. And the test vectors also show the unwrap pieces. The removal of the wrap scheme actually makes the document significantly easier for implementers because they really only have to worry concretely about one scheme to comply with the draft. We do also provide a little bit of guidance for dealing with legacy messages that were generated in the form of RFC 8551, which had a fairly poorly specified header protection, which had a lot of things that we deal with here. And then perhaps the thing that I'm going to ask for your most attention on, which I will get to in the slide deck here, is that we had a contributor raise the concern that if the mail user agent prefers the protected from headers, there is a risk of from header spoofing. I'll get to that in a minute, but I just wanted to highlight that it seems like there might be a risk here, and we have some guidance about how to deal with it. And that's what I'm going to ask for working group feedback on most specifically. Next slide, please. I'm not seeing the slide change.
Yeah, one second.
Okay. Thank you. Okay, so like I said, the simplification where there's just one scheme is great. The draft is simpler and shorter, easier to deal with, and wrap message wasn't necessary. We were basically creating a new scheme that nobody had already used, and it was just, it didn't end up being particularly useful. Next slide. Okay, so how we currently represent the sender's initial intent of what goes on the outside of the cryptographic envelope is we had at the previous IETF an HP removed and HP obscured, and we had some great reviews that observed that with HP removed and HP obscured, as in the previous draft, we could not clearly represent distinct changes to multiple headers of the same name. Now, that's not a very common scenario. You certainly don't have two subjects, but we want these mechanisms to work clearly for things, even if you happen to decide to have multiple headers of the same name and you decide to do different things with them. The replacement is this HP outer replacement, and basically it simply makes a copy of everything that was put on the outside of the cryptographic envelope and puts it on the inside of the cryptographic envelope. It's simpler, it's a little bit less confusing, and it happens to handle distinct changes to multiple headers of the same name in a straightforward way. The pseudocode that we provide addresses how to use HP outer explicitly, and it's actually a nice cleanup. Next slide. Okay, I mentioned about the header confidentiality policy refresh. HCP shy, you might be interested to know, removes display names and time zone info, as we think that those are things that are not relevant to message deliverability or quarantining. And it seems like a plausible next step for a mail user agent that would want to be a little bit more ambitious about what things are protected in confidentiality for encrypted messages. Next slide. Okay, here is the risk that I really want y'all to pay attention to. So it was observed by a reviewer, thank you, Alex, that if a mail user agent always prefers the protected from header, and they also, maybe implicitly, depend on their mail transport agent to ensure that the from address is authentic, for example, by quarantining messages that don't appear to have the correct from address, then this draft would have opened a way for someone to smuggle a bad from address into the message. So the example that we like to give is, you know, I send the message, it's from, on the outside it says from dkg@fifthhorseman.net, and that's all DKIM signed and everything, is delivered just fine. And then if your mail user agent does this, and you unpack this protected message, and instead in the from address, I've got on the inside, the protected from says from, I don't know, trump@whitehouse.gov, I can land a message in your mailbox that I don't have the right to send mail from. And if you're dependent on your MTA to do the kind of quarantining that we know is fairly common with DKIM and DMARC today, this opens up a hole in that particular protection. So that's a risk. We don't want that to happen. The draft now outlines that as a risk and proposes some guidance. The guidance is a little bit controversial, even within the editor team. And so we hope that in the process of your review of this, you'll take a look closely and tell us whether you think this outcome is a reasonable outcome or if you think something else should be done. Next slide, please. All right. This is the old version of my slides. I asked for an update at the beginning of the session, but I guess they didn't make it in, so I apologize. The other one, the newer one, has highlights, which makes it a little bit easier to read. So the current guidance says, if you have a valid end-to-end cryptographic authenticity of the signed message, and it is signed with a certificate that you know belongs to the protected from address, it is still okay for the mail user agent to render the protected from address, even if it doesn't match the outer from address. That is, what the draft is saying is strong end-to-end verification of sender identity is sufficient to bypass whatever MTA quarantining the MTA might have done. Most users don't have any idea whether their MTA is doing quarantining or verification. But the argument in this draft is if you can confirm that this is a valid signature from a valid certificate for the protected from, it's okay to show that to the user. On the other hand, if the certificate is not valid, or the certificate has an address that does not match the protected from, or the signature is not valid, then we expect the mail user agent to show the from address that the mail transport agent would have used for filtering. That is, to show the unprotected from. Now, this last point is a controversial point among the authors. One of the editors believes this should not be done, and we're in the process of discussing that. If you're following the issue tracker, you can see it on, I think it's issue 85. Another little wrinkle here is that in terms of matching the from addresses, either with the cert or with the mail, or the protected from with the outer from, you have to have a routine to match two adder specs. And this document attempts to describe how to match two adder specs. Those of you who are RFC 5322 nerds might want to come in and tell us how to do that better. So this is something that I think we really need people to look at. But we believe that the risk is there. It is real for folks who depend on their mail transport agent to do the from address quarantining and verification. And we think that the guidance that we've offered here is reasonable guidance. Next slide. I think we can skip this slide. That's just about the end-to-end mail guidance, which I already said we don't need. And so, yeah, in my updated slides, I asked for two things. One of them specifically is a review of the from address spoofing guidance. And then also we hope that this document is finally ready for another working group last call to get it across the finish line. So that's a lot to dump on the working group here all at once, but the document is actually in much better shape than it was before. We've had many more commenters, much more feedback, which is great. But we still need the working group to give us some perspective. I see Bernie in the queue.
So quick question from a chair perspective. Is this the last substantive update?
It's always the last substantive update, Russ. Let me be clear. If the working group tells us what's going on in the from address mitigation is not acceptable, then we will do another substantive update.
Okay.
Among the editors, and Tore Goebel, I want to call out specifically as someone who's stepped up not as an editor, but has stepped up as a significant contributor. Tore is offering suggestions for how to improve the guidance on replies, in addition to guidance on what is rendered. So that discussion is happening right now, and we would welcome feedback from the working group on this.
So, as the slide says, you're ready for the working group last call at this point.
We want the working group to give us the last call business here.
Okay. All right, Bernie.
Well, I'm the one that is not agreeing with this rendering the unprotected from. I explained that in an email today on the LAMPS mailing list. Basically, my proposal is in this case, we have an invalid certificate and that is shown to the user, and the user should deal with the situation no matter what's going on the outside or not. He sees that something is wrong, he has to deal. And just rendering something that is dependent on DKIM or whatever, which is not really giving any real improvement, as DKIM is a much weaker matter and can also be forged. I don't think this is a good idea. It makes things actually worse. And please read the email and answer to it, and that's it.
Thanks, Bernie. I want to just mention that there's a question about whether it makes things worse than the status quo for mail user agents that don't implement header protection, and whether it makes things worse for mail user agents that do offer header protection. I don't actually think it makes things worse for mail user agents that don't implement header protection. I think it's basically what we currently have today. And I also want to flag that the end-to-end mail guidance document, which has been sitting in misref state, waiting to go through the auth 48, explicitly says that when a signature is invalid, it is recommended to not show that in any more scary way than a signature that is missing. And if the signature fails, then that does not guarantee that there will be a warning, as is described specifically in the end-to-end mail guidance draft. So just want to flag that, and it's just so hopefully that the working group generally can see where some of the fine nuance is.
Okay, anything else? Thank you. And thanks for all the work that's happened following IETF last call.
Thanks. I hope we get more feedback from the working group. We would really value any contributions. The stuff we've gotten in the last 4 months has been really, really useful and has made the document significantly better.
All right. So back to the agenda. With 8708 BIS, there's it hasn't reached IETF last call yet, so we don't have any feedback yet. And we had just done the publication request with the Falco attack mitigation document, and that we've not even gotten the security area director review on yet. So that is the end of the ones that we were going to cover before we pulled up the 2 slide decks that are have to be today. So Sean, you're up. CMC BIS.
Awesome. All right. Hello, I'm Sean Turner. This document is currently out for a working group call for adoption until the 30th. Please say yes. Next. So it's out for working group adoption. Awesome, really appreciate it. We're still plugging away on it, making PRs, but we're kind of pausing merging them because we think it would be pretty bad to merge them on a document that we're agreeing to. So we're going to wait. And the nice thing about GitHub is we can just transfer it over and it works. You can track them all. So the really big one was to look at, because CMC is currently in a working group last call, and you know, I volunteered to look at the stuff that was in CMP to see if we could use it in CMC. And I looked at it, and I talked with Mike, and I talked with John, I talked with Russ, and I talked with Joe, and it doesn't look like we need any of it. So they're free to do whatever they want, and we're just going to do our own thing too. Now, the really cool thing is it's all there already, which is I was actually quite surprised by, but very happy. Quick synopsis of CMC, right? It's a certificate management over CMS, and so it has defines some messages that you basically wrap in CMS. And you know, we've got this cool new CMSRI thing that we can use, so we're just going to use it. But the fun part is in CMC, it doesn't support indirect like CMP does, and I don't see any need to add it because the direct mechanism is really kind of a better approach. It sucks that you got to do multiple round trips, but you know, that's kind of life when you can't do a signature thing. So the basic plan is to use the existing no signature algorithm and the existing encrypted decrypted POP controls. So when you start looking at the messages and the flow back and forth, you go, oh wow, that looks a whole lot like that RSA example in Appendix B. So I stuck in a new appendix, or a new section in the appendix that lays out how you would do this stuff, and it basically looks exactly the same as the RSA one. I just put a little more information in there to use the new ChemRI recipient info choice, and it all kind of works. So the plan is the client sends a chem only certificate request with this dummy signature over top of it, sends it to the CA, and the CA goes, yeah, no dude, you need some POP. So he encrypts a POP back to the client, and the client has, you know, he can encrypt it because the client has sent the public key in the request, and the server's got his own certificate or his own key as well. And I sent it back. Now, Deirdre, you're looking over in the corner there. I definitely want you to look at this. And so the idea is you encrypt the POP, and then when the client gets it, he's got enough information to decrypt it now. So you basically shoot the thing back, and then the server says, yeah, hey, cool, here's your shirt. Bob's your uncle, right? Very simple, very straightforward. It's the same way you could do with an RSA only thing. But while we were doing this review, we did note that Mike, as he's quickly reviewing the draft, he's like, hey, it says the return POP is in plain text. How is that secure? It's not, right? So oops, there was a problem, but the examples had it right. So in the PR, if you click on that link, it'll take you to the PR. We fixed the text to make sure that was right. And the other thing I noticed, I was like, hey, look, you know, you make the signer info and you usually got a certificate, and there's 2 choices. One is, you know, issuer name and identifier, or issuer and name, or a key identifier. well, if you don't have a cert yet, you can't use that option. So I kind of cleared it up and basically said, hey, if you're going to do it, use the signer identifier. But we basically said, just put some dummy value in there because it's the one that's in the thing. And we picked 4 bytes of zeros. If you'd like ones or lamps is great or whatever in there, we can do that. We don't care. I'm not going to fall on that sword. All right, next. So some of the other ones.
Sean's big gray.
Yeah, Sean's gonna, I'll put a cat pick in there. Everybody be happy about that. So we had some 6955 text. Now that's how you do how you can do signatures with like Diffie-Hellman and elliptic curve Diffie-Hellman stuff. The problem was, it was minor, but it said, hey, there's 2 WIP mechanisms in that draft. It's actually 3. We added the pre-5378 boilerplate because Jim is deceased and I can't find Mike despite trying. So we gave up and we're just going to go ahead and stick it in there. We had some requirements for BCP 195, which basically says if you're going to use TLS, use these algorithms, right? Because the old one just said do TLS 1.0, and we thought that was a bad choice. And again, it's only if you're going to do TLS because CMC, like CMP, does not require you to use TLS because all the things are signed. So off we go. The examples, one of the motivating factors for doing this thing was to try to get rid of SHA-1 everywhere. So instead of, there was one where there was an HMAC SHA-1, I put, let's do 256. We incorporated another errata. The next thing that I'm really not looking forward to and talking with Joe is we got to update all the crypto requirements. So CMP has this nice little profile of the things that you would use these various algorithms. You look in CMC and you're like, whoa, why do we, well, I know why we did it because it was great back then, but now it's really horrible because it's like SHA-1 and RSA and some other weird things in there that you must do. Oh, and DSA as well, because everyone followed that direction. So we're going to try to up those to do something that's more interesting. And I'm hoping that you'll all help me because I'm going to be just picking some like a shot in the dark. Like, do we really need RSA OAP? Like, I don't know. Is that one of the ones that we want to do? So some of you are making good faces. So that means I know you're going to want to read this. And then Carl Wallace just submitted an erratum, which basically, as they were going back through CMP, was about whether you put a null in or a null DN. And so he's like, it's just a typo, fix it. So cool. And I think that's it. Hendrik.
Questions?
I knew
Hendrik.
I knew he was going to be in the line.
Hi, Sean. Thanks for taking a look at the CMP stuff. And I had a quick look into your pull request, and I fully understand the approach on the direct pop. But what I was not in the time I had able to see, do you not need any CAM-based message protection to kind of authenticate like key update request or revocation request with a with an old certificate or with the old key material?
So we don't have this. What I looked at, the only thing I looked at including was doing a you're starting from scratch. You're starting from new. I didn't have one where you had an existing one where you're going to do an update mechanisms. I didn't even look at that.
Okay.
That's a good question. So does renew require it?
That's a good question. Hadn't even thought about it.
Okay.
So it's something that's something we can look into. Joe, you're taking notes, right? Right.
Yes. So the 2 things we did about CAM support in CMP was the one was on the POP. So the indirect POP is a message that is preferred in CMP, not the direct POP as in CMC. That's clear. With the message protection, this is only needed if you want to authenticate a key update request or revocation request. So I'm curious to see.
So it's for rekey, not renew?
Yeah.
Thank you.
Fair enough. We'll look into it. Because to be honest, I didn't even think about it. So thanks. I appreciate that.
Okay.
And again,
Thanks.
It would be something that we would do in the working group at the direction of the working group.
You're direct.
Cool. Well, I'll make a PR. I just won't merge it till later.
If it's adopted.
All right, cool. Again, get out there, say yes. Be positive thinking. All right, cool. Next.
Vote for Sean.
For what? I don't know, but all right.
That's your last slide.
I know, cool. Let's go to the next presentation.
That was your last
Next
slide.
presentation.
Next presentation.
Well, the next one's Hannes, right?
No, the next one's Hannes.
Oh, it's Hannes and then me.
Yes.
Okay. Awesome.
Actually, I want the other deck, the CSR attestation first.
Yes, you're right. I was just assuming there was only one freshness draft.
I thought
There
was
is
two.
only one fresh.
How is that not the right one? Yeah, isn't this the one that I threw up?
But I wanted the CSR attestation draft.
That's the only freshness set of slides.
The
we have.
CSR attestation
Draft.
is not the freshness draft.
Okay,
It's two separate
it.
documents,
Got
but
it.
still good documents.
that's where I was getting stuck. So
That
thank
was
you.
a little too low hanging fruit, I guess.
That's right.
And I've Mike is on is remote.
That's what we moved
He
on.
was
Yep, that's
initially
fine.
planning to give this talk, but he's not here. So if the microphone works, his microphone works, he can jump in. So I'm obviously giving you a summary on behalf of the authors and also on behalf of the design team. So there's a design team that meets twice every second week, not twice a week, different thing.
Different week.
Yeah. Next slide. This is sort of the high-level summary. So you should have seen that before. The idea was remote attestation evidence in a CSR to provide some information about the security properties of the endpoint and the key that resides in that device, the private key, when it's sent to the RACA, so that there's some information to the CA to make an assessment of when to or whether to publish a certificate or to release a certificate. And for that reason, a couple of extensions have been defined to carry this attestation evidence, but also certificates related to that evidence to facilitate the certificate validation. Okay, next slide. So since we meet quite often, we obviously have a lot of opportunity to discuss open issues. Russ kindly started the working group last call, and there was a lot of feedback, and so we tried to or we worked through that feedback. Next slide. Very briefly, a summary of what we changed. I'm ignoring the editorial aspects here. We had different ways. So from early on, we want to have different representations of certificates, which we then, based on suggestion, we reused RFC 626080. So I think that was a good change. We also made some modifications to the way how the relationship between the different evidence bundles can be expressed. So in some cases, some simplistic cases, you only have one evidence being sent out from the attester to the RACA and then subsequently to the verifier. But in some other cases, in more complicated devices, you may have multiple sources of evidence because this is a composite attester, for example. So this may be, for example, the case when you have multiple processors on a single device, or you have some server-based infrastructure with a confidential computing. You have trusted I/O, where the TCP is actually extended out to the peripherals, network cards, graphics cards, and so on. So they all then provide attestation evidence from these different peripherals. So that's where you end up having more than one evidence being sent out to the RACA. Okay, next slide. Yeah, we got IANA early allocation for helping us to do the implementation work. So we have some running code. Next slide. That was a little bit of a controversial issue, and then I'm already at the open issues here. So we included, let me start differently. So when the attester sends evidence to the RACA as the relying party, it, in the way how the RATS architecture works, it has to pass on that information to the verifier, because the verifier is the entity in the RATS architecture to process that information. And in order to process it, it needs to understand, obviously, the evidence format, of which there are a couple of. Go to the RATS meeting to see sort of like the scale of it. But it also needs to have a trust anchor, it needs to do the signature verification, and equally important, it needs to match and verify the values that are in the evidence. For example, reference values related to software that is on the device, or information about the hardware, like endorsements. It needs to verify all of this. So that needs to be available. And so therefore, the RACA, as the relying party, needs to pass on that information to the right entity. And in some larger deployments, there may be multiple of those, potentially operated by different parties. We don't talk about, like, we don't mandate a specific deployment architecture. You can munch everything into a CA if you like to do so. And it turns out, in discussion with Mike St. Jones, I don't know if he's here in the room, that's the deployment model he wanted, and he didn't like other deployment models. That's why we had the discussion on the list. But others want to choose a different deployment model. So we wanted to facilitate these different deployments models with this, as the error indicated here, a hint, which is a hint to indicate on where to send this, to which verifier to pass on that information. Of course, with security considerations and so on, which we have in the document. So that's one of the big open issues.
Could I jump in? Because my audio is working.
Sure.
I think the high level issue here is this looks like a type statement, like a type value type structure, right? You have an OID and then some data. And normally the OID is completely unambiguous. Normally in these types of structures, you parse the OID and then you know exactly what to expect in the data. The problem with attestation is that there's a billion different formats. And in addition, there's at least a handful of different wrapper formats. Like WebAuthn is a wrapper format and CMW is a wrapper format. So we're already starting to see that the OID for the type says CMW, but then you actually have to parse inside CMW to find out what proprietary, like what's the actual data at the bottom. And so the debate here that Hannes was referring to about architecture is, should the RACA be responsible for parsing that first layer of wrapper formats? Should it be responsible for knowing how to parse CMWs and whatevers? Or should we somehow drag that up a layer through this UTF-8 hint so that the attester can give a hint to the CA about what the actual sort of bottom turtle of that statement is? Does that make sense? And it's a bit of a controversial issue, because some people say, well, no, the RA should just have a full stack parser, and other people say, no, the RA shouldn't have a full stack parser, it should delegate.
Yeah, so thanks, Mike. Yeah, so it relates a little bit to the deployment model. So if you munch everything together, all functionality into a CA, obviously the question about do you process that locally is kind of moot, because you're doing it anyway. But if you outsource that functionality to a different entity, microservice, or a different server altogether, or who knows, then the question becomes on, like Mike just mentioned, how deep do you really have to dig into the details to make a decision about where to route the request? And that's where we had this discussion, and unfortunately no real conclusion on this. So obviously feedback would be appreciated. I understand that this is sort of very deep into, at this point in time, into technical deployment issues that not everyone here may have a strong opinion about this, but I wanted to bring it up nevertheless anyway. So if you plan to deploy remote attestation with CSRs, this is something you will stumble over at some point in time. And then maybe you want to have a chat with us about this. Okay, next one. Yeah, we have a bunch of open issues as well. Mike, could you summarize something here on that slide?
I don't. Yeah, I don't think we need to go into these in detail. They're here for people who want to review the notes for the sake of transparency. So I just earlier we mentioned that there were 14 issues I think raised during the working group last call. These are the ones that are still open. I just want to be transparent about what's still open. I don't think any of these need debate. I think these are all relatively straightforward. We just need to do them.
In the appendix, we have a couple of examples, sort of like live examples. And Monty has put together or has written code for the DPM-based key attestation. And so that's something you could look into. It's referenced in the document. So there's a link to a repository where the code can be found. I think that's quite helpful if you plan to like play around with this, put a prototype together, or like showcase something to your colleagues.
Yeah, somebody besides me looking at it.
We can't hear you on the remote people.
Oh,
Yeah.
Just mention somebody else.
Raise your hand.
Hank.
No, so this is Henke. This is not Monty. The RX architecture does not actually define attestation very much on purpose because it's a stupid word nobody should use. Thank you. And actually, really. So always qualify like key attestation. That's fine. And we talked about the key attestation claims to be a separate document, another working group. I forgot what it was. So there will be improvement on that. It's evidence, or it is attestation results, or it's the activity of remote attestation. And I will, of course, reply to the issue, but I wanted to speak it out loud here so that everybody can hear it again. Attestation by itself could mean that you're filling out the secure attestation software form from the government, which is a piece of paper with checkboxes that your boss signs and then it's sent via mail, paper mail. That is an attestation. So if you want to look for a good definition, you could also use the RIV document in REDS. It's in R48 forever because it was blocked by Chara. Both are unblocked. They are now moving. There is a term definition of attestation. It's like a kitchen sink definition. I would also refrain from using it here because you definitely mean evidence in remote attestation, and then just refer to the REDS architecture, but it is a name, so you can actually use that, and that's good enough.
Yeah, that was like we keep track of all the feedback that we get on the mailing list, so that was one of them. Probably this issue will surface in other places.
I'm going to jump here for the sake of the LAMP's agenda. Let's try not to debate these live unless we need to. Please comment on the GitHub issues.
Yeah, just a short comment on the because you mentioned that you have NIST definition. There is a NIST definition of attestation which you might consider, which has some other problems. Yeah, there are two of them, but I'm talking about the first one, which is most closely relevant to what we have in the draft actually. But my question is a bit different. So you in the first slide, you claim that basically you are covering all kind of evidences. That was the claim, right? But I do not see any discussion in the draft on the trusted execution environments. How does this map to, let's say, SGX or TDX or CCA or things like that? So can you...
Do you want to provide an appendix? We would love to include it.
Sorry, say again?
I mean, so the draft just says, here's an octet string, put whatever you want in it. I mean, we don't need to exhaustively list all possible things that can be octet strings. But if you want to provide an example that shows how to put SGX attestation, we'd love to include that.
So that would support, that would basically support any custom format, right?
Yep.
Yes. Yeah.
Okay, thanks.
Yeah. And we have a few people volunteer to provide some format. So I put a DSA example together, the Monty, a DPM example, net, a DICE example. But if someone else comes along in time, then we also include a confidential computing with TDX example.
Yeah, I guess a little late now, but as I say, please provide more examples as proof of concept that we did this right. I did the TVM example. It'd be great if somebody else besides me looked at it. As far as I can tell, nobody else has looked at the actual source code to make sure I get it right.
We did it during the hackathon.
Yeah, we did during the hackathon, but afterwards,
after the hackathon,
it'd be good to have some review.
Okay. Next slide. So those are the open issues, I think. Did I exhaust my available time already? Next slide.
That's your last slide.
Oh, okay. That's the last one.
You're all done?
You're done. I
No,
think.
the other document. But it's very quick.
The other freshness document?
The real freshness document. So while you bring it up, just so there's a document that talks about sort of fresh. It's called freshness. So this document is just a CSR and information included in there for attestation evidence. But in many cases, what you also want to have is, as a relying party, some assurance that this information has recently been generated, so that the attester applied his private key to sign the evidence just recently. And this is what this document does. It basically includes an exchange to provide a nonce from the relying party over to the attester. And attester then typically, that's what the different attestation technologies do. They then pass this into as an API call to the attester, so that it can then generate the evidence, which includes the nonce then consequently. And then the relying party, when it gets the signed evidence, it can then verify whether the nonce was included and thereby whether the produced evidence was fresh. It doesn't, of course, mean that the values inside have recently been generated. That's a completely separate topic, because some of it may never change. For example, the information about the hardware. Obviously, like even if you sign it again, the hardware won't change, right? It's always the hardware, the values, the claims describing the hardware will remain the same. Some other claims may change. For example, if you do a software update, obviously the firmware may change. If that's what the software update is about, then that value will be new, and it will be a new value in a claim in the remote attestation evidence. Okay. So this, since the CSR is a one-shot message, this information needs to be conveyed outside in a certificate management protocol like CMP, ESD, and CMC. And so, next slide. And
That
so
was
there's
a lot of words for the title slide.
That's yeah. Thank you, Russ, for the feedback. So the document was adopted in May. We produced a new version. When you look at the diff of the version, you get the impression that we rewrote it entirely, which is due to the editorial changes we made to the text. But there are a couple of to-be-dones in the document, so it's not super complicated in some sense, because like it's a round trip after all. There's some text that will come from Sean on CMC. Currently, this document covers CMP and ESD. It also is impacted by the hint discussion we just talked about. And there are a few minor open issues related to what are the capabilities and alignment with the RATS sort of concept. So this is something that you would typically need on top of the previous presentation, this attested CSR in a complete system. And what did I put on the next slide?
That's it.
Okay, cool. Yeah, so that part is.
You talked more to the title slide.
So I disclosed everything already under the title slide.
Yes.
So that was questions, of course, why I put the second slide in there, but that's a presentation style issue, probably. Yeah. Henk, do you want to say something?
Yeah, just one quick question. Is this idea is marked down on the LEMS WG organization GitHub?
No, I asked him to move it over there, and he
Ask him.
Oh, then I asked the wrong person. So I will work with Sean today or tomorrow to move it over there.
Expect PRs.
Yeah.
We delegated.
Very good.
All right, Sean, you're back.
All right. So which one is this?
It's the lithium certs and Kyber certs combined.
This one, right?
This is a 2-for-1 presentation, and sorry if I may have dropped the ball about moving that repo over, but it's like clicking a button, so that'll be easy. All right, so we got 2 certs, one for not MLS, DSA. I cannot believe I did that. Clearly, I've got something on my brain. Sorry, it's MLS co-chair. It's one of my other gigs. These are for the what used to be called Kyber and the lithium. Let's go next. So the DSA certs, we did some alignment. I kind of read the 2 drafts. I'm like, Jake's leading one and I'm leading the other, and I guess we had some stylistic differences. So I tried to merge the 2 and put them together. Like, for example, I had like a blurb about the ASN module. He didn't have it, so I just copied it over there. We had he'd use the 88 version of the ASN1 identifier or algorithm identifier, convenience example there, and I used the 21 version. So I changed it in the new one to use the 21 version. John Madison had said some comments, and we fully incorporated all of them except for one. He wanted to have references to like how this could be used, MLDSA could be used for a bunch of other things like OCSP and a bunch of other things. And I basically said, it doesn't really belong in this particular draft. There could be another draft. And now I'm talking with Russ and somebody else about doing the MLDSA with CMS draft. And that's where we can define the constructs that can be used to sign things. I didn't want to put it in this draft because the other drafts are going to take a lot longer. And I think this one's probably a little needs to get out faster. And to do so, the other thing is that's running around is this private key text that we had in there. We had some misalignment amongst 3 drafts. And so again, it is just the raw key that gets stuck in there based on the constructs for the public key certificate format. But there are some other words in there that made it a little more confusing. So we're going to try to take the text that was in the SLH DSA draft and copy it over, which seems to be kind of like it's raw. But if you did need to ship it around, just stick in this octet string, which is basically what it is. Now, the only reason why we really care about this is because if you do export it and ship it around, you're going to stick it in PKIX. So that's all that we're talking about. We're not trying to put any strings or anything in the front of it, none of that. And obviously add some voids when we get them. Next. This looks very similar to the previous set of slides. Again, tried to align the 2. So we added some tried to make it a little more stylistically the same. We had 2 sections that seemed like an arbitrary split, so I just kind of merged them together. And for some reason, we had the FIPS-pub reference in an informative section, and that is incorrect. It should be a normative one. So we moved it up. Again, what's left to do is align some private key text and add some voids.
Privacy text.
Private key text.
Oh, okay.
Yes. Use this to get privacy. That's it. Any questions? Again, we're mostly just kind of waiting. And again, if you would read for any of the stuff that I didn't get between the 2, or there's editorial fixes and stuff, we're definitely trying to not be controversial here. All right, cool. Thank you.
Thank you. All right, back to the regularly scheduled agenda. Henrik, we're going to talk about 4210 bis.
Yeah, I'm happy to do so. So, yeah, this is the status on 6712 bis and 4210 bis. Next slide, please. So the 6712 bis is a HTTP transfer for CMP messages. It is mainly complete for a while and waiting for 4210 bis to complete. I had an IANA early review comment last week. I included it into the version on GitHub and will submit the update with the next version to the data tracker. But finally, this is it. Next slide, please. The 4210 bis since last IETF. So during last IETF, I presented some issues we discussed on the GitHub issue tracker with some people and asked for guidance. And after the last IETF, we continued and the discussion and changed some things as proposals, and there was no no disagreement with. We removed some normative language from section 422. We did some changes on the root CA key update content resolved in erratum. We did discuss on the recipient identifier used in indirect and direct pop methods, so that refers to the same topic Sean raised with the CMC, that if you use a key to deliver a certificate or an encrypted value where you do not yet have the certificate, but only the private key, then you cannot use values from a certificate to point at the key to use. So we decided in CMP the client anyhow needs to keep a state of the transaction if you have several round trips, and therefore this as an indication is not, this recipient identifier is not needed anyhow, and therefore we added respective guidance. Good. So we did ask for working. So we had a working group last call. It was extended until July 12th. We got some review from Tom Vickers and from David Hook, and yesterday or today, I don't know whether what was your time, also from Sean. I will explain on the feedbacks from Tom on the next slide, but mainly the question would be to the chairs on how to proceed now, whether we close the working group last call, whether there will be further review to be expected. So I'm always happy to get feedback on this CAM support. It is not that easy, and therefore I'm really happy to receive comments and feedback and guidance from the working group.
So Hendrik, what my thought was at this point was we were waiting for the last review, which Sean did earlier today. So I think we're done unless the authors are going to ask for it to be held to do the nonce request, nonce response.
So from the feedback, as I understood it, I didn't have that much time to dig deeper into it. As I responded earlier to Sean, I felt like it is mainly on the POP and not on the message protection side.
I think Sean's saying you guys can proceed, and the only thing he's got to look at is whether CMC needs to deal with the rekey thing. That had nothing to do with CMP.
That is right, and that is also, I don't know, I wouldn't call it a review on what
No,
how we
there
do
was going to
things
be a
in
review.
CMP.
Turned out he had nothing to say.
Okay, so if the feedback, so the review feedback from Sean is like, it is fine how you do it in CMP, then I'm happy. If it is, I just checked whether I need anything for CMC, but didn't care about how you do things in CMP, then yeah, may also be okay.
Either way, you're unblocked.
Okay, thanks.
So now it's up to you to tell us nonce request, nonce response. Are we waiting for that or not?
So there are other of the authors in the call. So does anyone, Mike, John, do you have a preference?
I haven't even thought of it. Actually, you have a second.
I didn't hear that. Can you come to the mic?
He's going to the microphone.
Sorry, yeah, John, I'm just about to fall over the mic. Yeah, I hadn't even really thought about that holding us up. So, yeah, I mean, if we think it's going to delay it for a long time, if we think it's a couple weeks or whatever, then that would be okay. So not a couple weeks, a couple months. Okay, everyone's saying yes, a couple months, so then I'd say, let's not hold it up.
All right. We're gonna ship it.
Yeah. So as I see the nonce request, nonce response syntax is really a very isolated thing. So it is one section in, I think, 5.3.19 to add one additional general message type. So it could be potentially added also later because it doesn't affect anything else from the draft. Okay, so I'm happy to proceed with the document. Okay, next slide, please. So this is just the recap on the way we do message protection. And I put in bold the CAM context, where we said, also following to the CMS CAM-RI, there can go in some additional context information depending on the CAM algorithm used, whether it needs additional things like CT or public key, which was extensively discussed on the CMS CAM-RI draft. So if there is something, there is a place where we could put it. Next slide, please. This also goes, so on this slide we have the feedback, the three main points coming from Tom on the message protection, and one was also on where to put such context information. I just showed how we are considering this. The first was a general topic, where do KDF parameters go to? So they are in the parameters, a component of the algorithm identifier if the KDF uses or needs them. At least, so I'm not the expert on this, at least that is how I read the respective documents. So the next point was this discussion on the context information I just explained upon.
Yeah.
Back to this slide.
There you go.
We can hear you again.
We hear you again.
Sorry?
Yeah, we lost you for a second.
Sorry. I just asked whether there is any comment on this slide.
No, no one's gone to the mic line.
Okay, next slide, please. So the feedback from Tom on the CAM-based POP. So the two first points kind of were responded to. We are reusing something from CMS, so CMS envelope data. With the CAMs, we use the CMS CAM-RI, and therefore we definitely have a KDF is involved. And also I feel like the CAM re-encapsulation attack is significant, or at least addressed with the CMS CAM-RI. The last point was on a security consideration in the direct POP, where we where the RA requests to decrypt a challenge by the client and responded. The CMP 4210 says that the decrypted challenge is responded or returned in clear. And he said, yeah, why not returning the hash of the rand, like it is also done in the CMC. We did not really touch the direct method, as this is a sideline in CMP, and therefore we did not change anything about this. If the working group thinks we should look into it and consider changing it, we can align in the group of authors to do so. Is there any opinion on this?
Everybody seems happy. To let you make the decision.
Thanks.
Oh, we have one.
We have one.
Hi, I'm Sophie from Google. Shouldn't we HMAC the entire certificate request with the shared secret to avoid any kind of misbinding attacks? Like if you only give the rand out again, then I could forward that and like put it in my own certificate request or something. If you have the entire certificate request HMAC with the shared secret, you would avoid that.
So if we do message protection using CAMS, we first, in a first round trip, establish a shared secret and then HMAC the whole message, the whole request message.
Okay, then I misunderstood that.
This is about the POP. If you provide an encrypted value and request to respond, a proof that you could decrypt it, you could either respond the plain text value, or you could respond an hash on the plain text value. This is what the point is about. But thanks for looking into it. Okay. Good. So then next slide. I think that's it.
Yep. Thank you. We just posted the consensus call while you were talking.
Thanks, Russ. Okay.
All right. So back to the next thing on the agenda is 7030 CSR attributes. Michael Richardson thought he was going to be here. See? There he is. Okay. You had no slides, but you
sent an email to the list.
You
right?
sent some email, I thought, to us. Do you want to say those things at the mic?
Sure, since we're so blessed with so much extra time.
Oh, well.
Yeah. So we did a working group last call. This is on CSR attributes. This is the clarification draft on 7030. And so we had a working group last call. I don't really remember when it started or ended, but it was recent since the last IETF. And one of the things we added in this is the ability to essentially to use a CSR as a template in the attributes to return what it is you would like. So, give me a picture of what you want, and I'm going to give you a picture of what I want, and you're going to then color in the gaps. The catch is that many of the contents don't have invalid or empty values that are actually parsable by a stock ASN1 CSR parser, and so there was complaints that this was a problem. And so Carl Wallace, I believe, has come up with some alternate ASN1 that has some empty values, but is still essentially bit on the wire compatible. So if you have such a parser, you would need to use the other ASN1 that actually accommodates empty values. I don't think we're completely convinced it's bit for bit compatible yet, that there may be some bugs in the ASN1, and that's going to get merged in the next week or two, and then we'll ask for another working group last call. And that's about it.
Thank you. We did CSR attestation earlier. And so we're now to X500, X509 with the stateful hash-based signatures.
All right. Hi, everybody. This is a combined presentation because it's basically just a single page each. First is X509 stateful hash based. Next page, please.
Can you turn up the gain on your microphone a little bit?
I can hold it closer.
Much
Okay. Excuse me. All right, good. I brought my cheap microphone with me. Okay, so since 119, it was adopted. Thanks, everybody. It was already in a pretty good state. We've made updates to refer to 8708 biz because previously it only referred to 8708. We removed any extra ASN1 wrapping of the public key to align with 8708 biz and the rest of the NIST post-quantum excuse me, drafts. We received ianoids for XMSS and XMSS MT. Thanks, Russ, for the assistance. Added certificate examples, which had mistakes, so they've been fixed locally. So the next draft will add those certificate examples. Private key wrapping. This was something that Russ brought up about RFC 8708 biz on the mailing list. He hasn't updated anything on his drafts, so if it's going to stay the same, that's fine. As it stands, all of these drafts, or this draft and 8708 biz, say absolutely nothing about private key encoding. Sorry, I should say private key encoding and not private key wrapping.
Well, octet wrapping, right? It is what we're discussing.
Well, it seems to me that the drafts say nothing about how to encode the private key at all in PKCS 8 or 12, and that's actually fine with me because, well, stateful hash-based signatures are a minefield, and in the absence of telling people how to manage the state and export the state properly, telling them how to encode the private key is like throwing a foot gun in the middle of a minefield. So.
Right. Scott Fleur wants to make a comment.
Sure.
To emphasize, to agree with you strongly, I think that is a private key wrapping for stateful hash-based signatures is a really bad idea. You should not touch it.
That's what we're doing.
Okay, so I guess to that point, to that point, should we continue to say nothing, or should both this and 8708 biz add text saying explicitly we're not saying anything about wrapping? Don't do it unless you know how to do state management.
Well, 8708 bis has some words that say don't use the raw public and private. If you want to steal that text, go ahead. I'm fine with saying nothing. It's pretty clear from the ASN1.
Okay. And then besides that, we think it's ready for working group last call. So
does anyone have any issues they know about on this one? Okay, we'll put it on the list.
All right, thank you. And the next page, please. So SLHDSA in X509 also was adopted last time. The changes are adding SHA-2 shake fast and small descriptions of those parameter sets to the introduction, referring to the CMS Sphinx Plus to get the ASN1. Excuse me. More ASN1 was expanding the signature algorithms and public key algorithms lists, I guess, to include these OIDs. I don't know enough about ASN1 to know whether that's what's supposed to be done, so please let us know. Also trying to be super explicit about raw public key encoding. From Sean's presentation, sounds like he stole that text, so I'm happy about that. Also remove private key encoding text because that's already handled in the Sphinx Plus CMS draft. Added security considerations and filled out a table of strengths. Next steps is, like all the other NIST documents, to wait for OIDs. I have here pure versus prehash, but I heard in PQIP, I think, Ross or someone else said we're not doing prehash at all in IETF. So I'm happy with that. We'll just follow the crowd and only do pure. And similar, I guess, to what Sean has said, John had a request to cover other things like PKCS 10, CMP, OCSP. My question was, is there anything that precludes it being used in these? And apparently the answer is no. And we'll deal with it in the CMS draft or in something else. Sean?
Yeah, I think that's the better approach. I mean, we could put a note in there, and then the problem is references, right? So if you start sticking things in there for PKCS10, CMC, OCSP, CMP, you end up with this weird thing. So it would be something like, hey, you can use these. Here's a bunch of informative references. Seems kind of silly, right? So I think just putting in the actual CMS one totally makes more sense. So that's how I do it. But I guess I wanted to jump back to this prehash assertion that we're only doing prehash, because I thought I heard PQuip that NIST was going to ask whether we wanted to get prehash stuff. So is the answer definitely hell no? And then we don't need to do it? I don't want to derail us, but I thought I heard that. And if that's the case, then that makes it easier.
I
faster.
heard that as with regard to certificates, absolutely.
Okay.
I don't see any reason to pre-hash a certificate because it's kind of tiny anyway. So don't do that.
Okay, good.
Yeah. Oh, Quinn can answer, I guess.
Quinn Danganes, just a slight correction. I just said that we will have 2 versions, and I did not. That was all. And then
So I think NIST will provide 2 versions, but that doesn't mean that we have to use both versions.
Well, and the structure of CMS already kind of does its own internal by putting a hash of the message as a signed attribute and then signing the set of signed attributes. So it's already a prehash-like. So, all right, go ahead, Mike.
Just history on this. So Panos did and although I think I've changed my opinion since, a couple of years ago hashed this out, pun intended, on the mail list. And like Panos, I think, was correct to say, are there any protocols that do not pre-hash at the protocol and are big? Like, can we find one? Can we find this mythical unicorn? That's a problem.
This mythical unicorn.
We came up with large CRLs. And that was it. That was the only thing we could come up with. We came up with lots of, I'm aware of proprietary signed things. I'm aware of weird PDF extensions. I'm aware of, but like, yeah, I think with things that are in the scope of IETFs, large CRLs was the only thing we could find that wasn't already pre-hashed to some extent. That's the history. Thanks.
Okay. Next slide.
John's in the queue.
Oh, okay. Pokey.
It's also the left side. Yeah, it's John Gray from Entrust. I was just going to point out also, like, sending data to an HSM and you don't want to send a gigabyte to it is kind of a important use case for a lot of people as well. So that's another pre-hash use case. Just wanted to mention that. So there are use cases for it, but that's maybe not regarding this because this is about CMS. So
This is about X509, and I'm glad that certs aren't a gigabyte.
Exactly.
Yeah, I think a clear way to say it is there's obviously a use for signing large objects, and if you're signing large objects, you should pre-hash them. The uses of signing that show up in protocols tend to, which is what we do at IETF, tend to be small.
Okay.
Okay, thanks.
Your last slide, right?
Yep, that's it. Thanks.
All right, thanks you, Daniel. Next is Rohan on the key usage for IM. Is he here? All right, so let me tell you what the state of this is. It's been no need for an update for since the last IETF. So we're going to working group last call it unless someone has an objection. Okay. Composite. Was that all the time sucking out of them?
Yeah, I guess we have like 10 minutes. Yeah, so composite signatures, it was actually adopted, what, a month or two ago. So thank you, everyone. This is just about the O2 updates. You can go to the next slide. So the one change affecting implementation interoperability was just a very tiny thing. It was actually just clarity on the PSS-based MLDSA 44 and the 2048 and 3072. We just fixed the salt. We had, I think it was Tim that gave us a comment. We hadn't clarified that. So basically we're going to use a 256-bit salt when the 2048 is used and 512-bit salt. So that really is the only interoperability change. So if someone implemented it, that's just a clarity really. So you can go to the next slide. Yeah, so this slide, I've showed this before. The only thing we changed here is we kind of moved up. We changed, so we're doing the pre-hash of the OID. We changed that. We call it domain, same thing. Still bit compatible with the previous one. We just moved it up basically a step. So instead of doing it on step 2, twice, now we're doing it at the top. So it ends up being the same thing. So, and if you go to the next slide, the same thing for signature verification. We just do the domain and the hash together concatenated in that step instead of doing it down when it's doing the verifying. So not a big thing, still compatible, but actually will save you a step if you were actually doing it that way. So next slide. Yeah, this is just the list, same thing. We haven't updated them. I'll talk a little bit later. There's a couple changes that are probably being asked for. So you can go to the next slide. Yeah, so editorial changes. We added Scott Fleur because he's been helping us a lot and he always comes to our meetings. We have them every 2 weeks. We removed references to the parallel PKIs in the implementation consideration section because we found it wasn't adding value. And I think we had some comments about that too. We also resolved comments from Chris regarding FIPS. We added a use in CMS section, so we're hoping that will mitigate us having to write another draft that says this is how you use it in CMS because there's a section in this document that says how you do that. Obviously, if the working group wants, we can take it out and put it in a different document, but we thought might as well just put it in there. Saves us writing another document. Yeah, well, so I mentioned this part already, the OID concatenation part. I showed that. We expanded the description of the key generation algorithm. Oh, Mike, you have something you want to say?
Yeah, I mean, do you want to finish the slides or do you want to?
Sure,
I want to
sure.
sort of force the debate about the use in CMS, but I'm happy to wait till you're done.
Okay, sure, I can finish this. We added an SMIME caps into the composite signature definite in the ASN1 module. There were some editorial changes by Jose Ignacio Escribano. Hopefully I said his name right. So we find people just, go into the LAMPS working group and, make pull requests. So I guess people are really interested in this. And of course we fixed NITs as well. I think, Mike, maybe you want to talk now? I think that's it.
Yeah,
for
so
editorial changes. There's some more stuff afterwards.
yeah, so let's have the debate. And Russ, this is sort of, I guess, looking to you for guidance. Do you want, so right now we've got this document that defines the algorithms, and buried inside it, we've got this document that says, here's how you use it within CMS. By convention in LAMPS, those are separate documents. And we've written it with the idea that we could just suck that section out into its own document. What do you want us to do here?
Let me read it one more time and I'll comment on list.
Okay.
Thank you.
Thank you. Okay, so you can, is there anyone, oh, Michael Richardson, comment?
Go back to your slide with the output invalid signature.
Yes, okay. Should we go back a couple slides? So that one there?
Yeah, that one there. So of course that's kind of got a if it ends early, then the second signature failed. So that's probably something you don't want to put in the slide to tell people that they should take the early exit constant time. Pardon me?
It has to validate, well, like you must validate. We just wanted to make it clear you have
Yeah,
to
I understand that.
validate
I'm just saying that someone reads this like, oh, so I should implement it that way, and the answer is no, because you want a constant time signature verification.
Not for verify.
Why?
Because it doesn't have the private key.
But then I can find, all right.
And
Okay.
it's signed that needs that, not verified.
Yeah, all right. Fair enough, fair enough. Good, my bad. Wednesday afternoon. I was like, oh, yeah, right. We can shortcut. No, we can't. We should never do that anymore. Okay. Okay.
No, it's not.
Yeah,
shortcut.
all right. Good.
Okay, you continue then. So yeah, I can keep going to where we were.
I forgot I was a couple slides behind.
Yeah, so you can go to the next one too. Yeah, so outstanding issues. So I mentioned before, so we have this list of 13. So we have a large end user wants us to add 4096 bit combinations. We could replace, like there's 3072 ones, so we could replace that, or we could add 2 more PSS and a PKCS 1.5, then we would have 15. So if you have feedback on that, I mean, you have this way to combine things and people want to use their favorite algorithms. I mean, RSA 4096 is stronger, I guess, but okay, go ahead, Deb.
So without my hat on, why don't you ditch the 2048 ones?
Yeah, okay. Yeah, I mean, that's a possibility too. So good feedback. So anyone that has feedback, let us know. Yeah, and of course, we don't want this huge list too. If there's ways to pare it down, we would appreciate that. I mean, yeah, you've seen the list, like there's brain pool curves and all that stuff too. Any way that we can pare it down would be great. Okay, yeah. So there's some comment. Carl Wallace had a bunch of comments, and even some people on the list were saying, well, are you guys just not ignoring those? No, we're not ignoring those. We actually discussed with Carl at the hackathon. And I guess I didn't finish this slide, but anyway, it's a lot to do with the ASN1. So he did come up with, I guess, like I heard in a different draft, another way to make the ASN1 much more efficient instead of, because he compiled it and it produces lots of objects for each one. So it looks like his methods are really good. So we probably in the next few weeks will be updating that to add those comments that he had. We also had some newer comments just within the last couple of weeks from Peter Popis. I hope I said your name right. We haven't responded to those yet, but we will. So those are on the list would do. And oh yeah, and the last thing on the list, there's another slide of these things, but also we can make the domain separator instead of just the dir coding of the OID, we could hash it and then it would make it fixed length. So that was a suggestion that came up too. Right, so we can go to the next slide. Yes, another thing, so in the composite signature public key format, we compacted it down to take out, there's in the public key, there's redundant information in there. We took that out so the public key is smaller. The private key, we could do the same. It's a private key. We haven't thought that was something that was needed, but if people really wanted a smaller private key, that could be done. Am I running out of time?
3
People are leaving. Okay, yeah, I'll be done very soon. How do we carry? Yeah, and how do we carry the MLDSA public key? And what was I going to say about that one?
That's
that's the ASN run wrapping stuff. Yes.
Yeah, so we had a debate with Carl who suggested that we register an OID for not encoded or null encoded or something like that. It's just this is a whole debate that we don't have time for.
So
in
there's
this
still
slide.
a bit of discussion obviously going on about that. And then I just read that I guess the Open PT group, I noticed that Mike, you had submitted an issue about this just a couple days ago because they suggested that, so they have pairings of basically composite as well. So they had suggested MLDSA 65 and 87, both with NIST P384. So we don't have that exact combination. So if we did do this, I guess the question is, do we align? I think it would make sense to align. Again, this was just from what we heard 2 days ago. So if we did this would change the one algorithm, MLDSA 65, ECDSA P256, and we use P384. And they also recommended a combination with MLDSA 44 and Brainpool. So maybe we could just remove that one. So they didn't recommend a combination of that, so we could remove that too. So I think that's the outstanding
That is
issues.
it.
Oh, and the last, very important, this one is, so we had a very exciting results at our hackathon. So this is actually, I wanted to share. So we actually have 4 interoperable, basically for composite signatures. This chart is showing that we've had Bouncy Castle, OpenQS provider, Entrust, and CryptoNext. We actually have composite signature implementations. This table was actually, I mean, I cut out a little bit of it because we have all the other PQ algorithms in there too, but it was actually generated dynamically. We had a lot of really good GitHub action tooling that happened at the hackathon. So now people can very easily submit their artifacts and within just a couple minutes get, you know, basically an output that in this matrix, this chart is generated automatically. So I think this will help not just the composites. This is showing that we have good implementation, across 4 providers. But you can see the first one I included, MLDSA. It also shows there's a lot of people that interoperate with that. So anything else you wanted to mention about that, Mike? Last plug for our hackathon work. It's been going on for 2 years, but.
I mean, I can plug that. Yeah, so we built out some automation to automatically. So this is testing against the OQS Docker image. I'm also in parallel working on integrating the NIST ACVP test. So if you upload, so the hackathon stuff will automatically be running against OQS and ACVP. And we're fixing
Okay,
that
we've
in
used all our
Castle
minutes.
Wolf.
With that,
Thank you.
yeah, we're done. Yeah.
So
That was
thank
it.
you, and the rest of the agenda on Friday. Thank you.
Thank you.
We may have gotten lucky, but.
Yeah. Yes. Because they're not going to publish it as quick. Yeah. That is why. They said they're going to do the 2 mLs first.
It's unfortunate because that's the only one that the signature can fit in the MSDU.
Yep. Yep. But it also has a signature problem. Yeah. It uses the floating point. The verification doesn't design it. Yep. Which may not be compatible to the environment.
That's a good point.
Huh. Yes. Yeah. That's what we all said. That's unfortunate. Indeed.